Alright, we're going to talk about solving real-life problems today, and how you can use linear equations to model and solve real-life problems. So, the first thing that we're going to do is actually write a real-life problem, given just some random pieces of information. Describe a real-life problem that has the given rate and intercepts. Draw a line that represents the problem. So the rate is decreasing by 30 feet per second. The y-intercept is 150 feet. And the x-intercept is 5 seconds. So the y-intercept is always wherever we're starting. So I would start there. The x-intercept is kind of where we end up. Like, after 5 seconds, we're at 0. Or after 5, whatever. In this case, it's seconds, but since the x-intercept is 5, after 5 somethings, we're at 0 feet. So I might write a problem like a kite is 150 feet in the air, and I'm pulling it in at a rate of 30 feet per second. When will it touch the ground? So, one of these three things has to be the answer to your question. And two of them have to be given in the problem. So I used the first two, and I used the third one for my answer. You can do any combination that you want. You can ask for the rate, you could ask for the y-intercept, or you could ask for the x-intercept. So it's entirely up to you. Alright, next one. The rate is negative $25 per month, the y-intercept is 200, and the x-intercept is 8 months. So go ahead and write a problem that has an answer of either the rate is you're losing $25 a month, or a y-intercept of $200, or an x-intercept of 8 months. See if you can write a problem that goes along with those three things. Turn your paper over. The percent y in decimal form of battery power remaining x hours after you turn on a laptop is y equals negative 0.2x plus 1. Graph the solution and interpret the x and y intercepts. After how many hours is the battery power at 75%? So, we know that the y-intercept is 1 whole. The x-intercept we're going to have to find. And again, to find the x-intercept, we fill in 0 for y. So 0 equals negative 0.2x plus 1, subtract 1, negative 1 equals negative 0.2x, divide by negative 0.2, x is 5. And after how many hours is the battery power at 75%? Well, instead of at 0, I want to know 75%. So I would subtract 1 again. Negative 0.25 equals negative 0.2x divide by negative 0.2. And I get after 1.25 hours. Now, the only thing that I haven't done is actually, well, I haven't graphed it, but interpret the x and y intercepts. So, to interpret the x and y intercepts, I have to think about the problem. So, if I'm thinking about what the y-intercept means, I just said on the previous page that it's kind of like where we're starting. So if you're thinking about battery life or power when you first turn on your laptop, this 1 actually means that it's 100% battery life. And we're decreasing after that. So the battery life is going down from 100%, but it's starting definitely at 100%. And the x-intercept is kind of where we're ending up, and x represents hours. So we did say, or if we look at our graph, after 5 hours, we have 0 battery life. So in thinking about the problem, you may have to go back and look at what x represents and what y represents, but they should be logical things that you can find. The next two are extremely similar to the one that I just did. Go ahead and try those for a homework assignment. We'll go over them in class first thing tomorrow. Have a great night.